cells. So on the error trials, we can ask, what are the cells predicting? Are they actually predicting the true response, that is, the actual reality, whether or not the subject saw the image, or are they predicting what the subject reported, the errors, okay? And what we found was that for 75% of the error trials, the neurons actually predicted the correct response. So the neurons actually had better memory than the subjects, if you will. So this is interesting because you can think of many examples where you might, this happens to me a lot, where I would see someone and they would recognize me, and I would say, oh, I don't remember meeting you. But then later, I realize, and I can actually physically remember, oh yes, I met that person at that conference, we were standing by the drink stand. So there's often the case that the memory is there, but we just don't have access to it. And I would argue that these cells represent that memory that's there. There's a dissociation. They're the constancy. They're the real information laid down in stone. And somewhere between that information and the decision of the subject, there was a problem. And the subject reports that they didn't see the image. So we have, of course, neurons that have better memory than we do. So the take-home messages then from my lecture are that memories can be stored by changing the strength of communication between neurons. Strengthening those synapses during memory formation can involve changing the shape of the synapse, increasing or decreasing the contact with the presynaptic cell, and changing the protein complement in the synapse, increasing or decreasing the ability of the postsynaptic cell to respond to transmitter, and also changes on the presynaptic side, changing the amount of transmitter that's released. And then we've shown in our studies with epileptic patients that there are individual hippocampal neurons that show evidence for memory formation upon a single exposure to a stimulus, and also a second class of cells that appears to be generally tuned for detecting novel stimuli in the environment. And then lastly, by analyzing the error trials, we've shown that neurons can actually have better memory than the subjects. So this is the group of very talented people that I've been fortunate to work with. The studies that I talked about today were done by Shrish Mysore, who did the physical changes in spines, and all of the human studies were done by Yuli Rudishauser, together with Adam Mamalak. And I'd also like to thank all of the patients that agreed to be in these studies. It's very kind of them, and it's an absolutely wonderful opportunity. Not something we can do everywhere, obviously. And last, my memory makers, my little girls. Thank you very much.
Ringraziamo la professoressa Schumann per la bellissima presentazione. Se ci sono delle domande, la professoressa Schumann è disponibile a rispondere. Prego.
From time to time, I observe losing of memory, even during not very late aging, through, 40 years old or something like that. Do you know the cause of losing memory during the age of 40 or something like that?
So the question is, do I have any ideas about what causes the apparent loss of memory in a very young person who's only 40 years old. So there are several different factors. Some of them are quite hopeful and have to do actually with, if you imagine the different stages that I talked about, the encoding, the retention, and the retrieval, a lot of what people have focused on is the encoding part of memory. So as you get older and have many more things on your mind, in order to remember something, you obviously, especially in episodic memory, you have to pay attention to it. You have to encode it. In order to remember someone's name, you actually have to listen and make a conscientious effort to take that information in. And as we get older, we have many more stimuli in our environment and many more things on our mind, so we spend less time on the encoding phase. So people advise on behavioral strategies to increase your attention during that phase. And then there's also the issue of probably the least optimistic part is the laying down of the memory, and whether there are complicated problems with laying down the memory, and then the retrieval, which again, I think this phenomenon that I described, where the information is there, but you just don't have access to it. Again, I would think can be explained by the complexity of life as you age, that you have many more things to remember, many more things on your mind, so sometimes it's more difficult to pull those things out. It's very rare for there to be a true pathological mechanism for memory loss at age 40. It's just the complexity of life, so yes.
So, there are a couple of questions here. Yeah, there.
Ok. Vorrei sapere che cosa mi può dire sui ricordi rimossi, che stimoli dà il cervello ogni volta che abbiamo dei ricordi rimossi.
So what can you say about removing things you don't want to remember?
This is an interesting area of research, removing things you don't want to remember, but so far, at least in my opinion, the approaches for removing these things are not selective. And so there's some work that's being done, for example, to see if there are pharmacological approaches to deal with post-traumatic stress disorder, to remove very traumatic experiences. But those approaches have a cost, and that is that we don't have mechanisms yet for selectively removing the bad memories and leaving the good memories intact. So in my opinion, unless the bad memory is so disabling, I don't think we have a good approach yet, because you'd effectively be wiping the slate clean at this point. What about dreams? How do we retain or not retain them? There's some really interesting literature that I should have tried to squeeze in that has to do with sleep and behavioral experience, and some exciting studies that have emerged in the last 5 years or so that show that during sleep, at least rodents, they go through a sort of replay of the day's experience. And I think that dreams, which we really don't understand, may represent sort of a fragmented replay of many events in our life. So it's something that's very mystical, and we don't really understand well yet, but you can certainly anecdotally imagine how you take fragments of your experience and they come together in some sort of frenzied way during dreams. But what we do know is during sleep, it's very interesting in animal studies that there appears to be a sort of recollection of the day's events, and it's thought that this replay, as it's called, is a way of sending the information from the hippocampus out to other brain areas.
So then the message is sleep, otherwise you don't remember.
Right.
Excuse me. Since the importance of protein in synaptic function, is there any connection between nutrition and memory process?
So is there any connection between nutrition and memory